All right, now let's try another example. It says ballooning. A person in a hot air balloon observes that the angle of depression, now remember this means looking down, to a building on the ground is 65.8 degrees. After ascending 500 feet, the person now observes that the angle of the depression is 70.2 degrees. How far is the balloonist from the building? All right, so here's the idea. You have a guy in a hot air balloon. So I'm a terrible artist, but I'll do the best I can. You have this person, and they're riding in this little hot air balloon here. And this person, it says, person in a hot air balloon observes that the angle of depression to a building on the ground is 65.8 degrees. Now, a reminder, like I was just saying a second ago, the way you find angle of depression is you first start by looking out, and then from looking out, you go downward with your eyes. So you're looking straight out, and then instead you curve it down. It's at about 60-something degrees. Would they say 65.8? And so I'm going to make this a little bit more. 65 would probably be something like that. We'll say that is 65.8 degrees. After ascending 500 feet, so now the balloon actually moves up 500 feet. So they're here, they move up 500 feet. So I take my balloon here, and it goes up like that, 500 feet. Let me shrink this down a little bit so I can fit it in. Okay, so this is where we are now. Sorry about that. Let's just get this lined up once for all. And now it says the person now observes that the angle of depression is 70.2. So again, you're looking straight out, and after looking straight out, you curve your angle down 70.2 degrees to get to that building. So looking out, I curve down. This is now 70.2 degrees from here to here. Whoops, I started with a 0. Sorry about that. Let's do this again. 70.2 degrees. And down here is that building. I didn't ever label the building, but we have a building down here that we're looking at. We could label this 500 feet on this side. It says now, how far is the balloonist from the building? So if I'm looking at this, I'm looking for this side length here. That is what I'm looking for. I'll label it with an X. That is what I need to find, is this length. Now, how could I do that? Well, again, if you have a completed set, you can solve. Now, what do I mean by completed set? You have to have a side length and the angle apart from it. Well, I only have one side length. I have this length. It doesn't appear that I have this angle, but I could actually find it pretty easy. This right here would make a 90-degree angle. So that means this angle here has to be 90 degrees minus that 70.2 degrees that are sitting right there. So if I subtract those, I get 19.8 degrees. That's what goes right there. Now if I know that's 19.8, and I can find this one rather easily, this here, remember it was 65.8 from there, but I need to add these 90 degrees. So this one is 90 degrees plus 65.8, which gives me a total of 155.8 degrees. That's what goes right there. Now that I have those two, I can find this one. So I start with a total of 180, and I subtract the 155.8 degrees. When I do that, I'm left with 24.2 degrees. You could check it in the calculator, but I believe that's the right amount. And now I need to subtract this 19.8 degrees. And so this would become a 6 here, point. This becomes a 3, so that's now a 4, and it's just 4.6 degrees. That's what belongs there. It's 4.6. Now I have a completed set. I know that sine of 4.6 degrees over 500, I can use that, part of the law of sines, to solve for this missing side length. Now, I'm looking for the side length of x. What's its angle across from it? Well, we had 155.8. So I'd say sine of 155.8 degrees would equal that. Now, as I pointed out on the previous, you could solve from here if you like, or you could cross multiply and divide. I'll do the algebra. So when I cross multiply, I have 500 sine of 155 degrees, 155.8 degrees equals x times sine of 4.6 degrees. To get x by itself, I do the simple step of division, because right now they're multiplying. So I divide by sine of 4.6 degrees. So I'm going to go to my calculator, and I will type that in. So we go calculator, and I'm going to type in, I'm working with a fraction, 500 of trig sine of, let me go back here, 155.8 degrees divided by the sine, I believe it was 4.6. I'm going to check that one more time to make sure I'm accurate when I say that. Sine of, I'm sorry, yeah, 4.6. So we type that in, we press enter, and there's our answer, 2,555.6641. So I'm going to write this down as x would equal 2,555.66 feet, and that's after canceling that in the calculator. Let's make sure that I wrote that down correctly. Yes, I did. And does it say anything about rounding? No, it doesn't. So if we wanted to round, because usually when we talk about feet, we don't say 0.66 of a foot. You'd either change it to inches or round it. I'm just going to round it and say that x is approximately 2,556 feet. And that right there would be my answer. Now I have an application for you to try right here. And I'll give you the picture so you can use that.